For this example, we're going to try to get x by itself, and one approach is to recognize that if you have the same basis, then that means I'm going to rewrite it like this. If a to the x equals a to the y, and then those bases like cancel, that means that x equals y. I'm not sure why it did that, but it did. The x equals y. So let's see if we can convert that 16 to base 2, because this base over here, to the x, the 2 can't do anything. It stays 2. It can't go any further down. But 16, did you know that 16 is the same as 2 to the 4th? Check it. And therefore, since those bases are the same, that must mean the exponents are the same, so therefore x equals 4. Those bases like cancel out. We'll pretend they do. Now, if you've been using logarithms, you can also use logs. One thing is, you can convert that to log form. If you write the word log down, then the base of the log is the same as the base of the exponent. And then, since logs are exponents, the log is going to equal the exponent, which is x. And the 16 goes there. The definition, I use the definition in case you're wondering. That's by far the most important thing to use. Now there's something called a change of base that you can use also. Remember, with the change of base, the base goes on the bottom. So the log 2 will go on the bottom, and the log 16 will go on top. So now you can hit or type in log 16, close, divided by log 2, close, enter, and you'll get the 4 that way also. Or you can take that original equation and just put a log in front of both sides. And then that x will move in front. And then divide both sides by log 2. And those logs 2 cancel. Now we're back to the same thing we had over there. So if you like this approach, then don't worry about that. It just depends what you know. On this example, we're going to get x by itself. Now we could use this property that says a to the x equals a to the y, which means if the bases are the same, that must mean the exponents are the same. The bases like cancel. That's good to know if you recognize that 216 is actually a power of 6. Did you know it's a power of 6? Did you know if you take 6 to the third, you get 216? And so the reason why I'm using 6 because the 6 is the base over here, which means I can now use this property. Those bases like cancel, and we get 4x equals 3. And that's a lot easier equation to solve than what we had. And to solve that, you just divide both sides by 4. And x equals 3/4 is the answer. Now let's say that you don't know how to do that. You might want to use logs. So what you can do, and I don't know what you know, but I like to do this. This is just my preference. You can take the log on both sides if you want to, but I prefer to use the definition. Start with the word log. The base of the log is the same as the base of the exponent, which is 6. Logs are exponents. Since the exponent is 4x, that means the log equals 4x, and the 216 goes here. It goes in a circle. 6, 4x, 216. 6 to 4x equals 216. It's kind of a way to check it. Circle, buddy. And then there's a formula called a change of base formula, which says you can take that log base 6 of 216 and you can write it as 2 separate logs over top of each other. Remember, just know that the base goes on the bottom. And then we have the 4x over here. And if it were me, well, you can go ahead and then divide by 4 if you want to. I'm not sure if I would do that yet, but it's totally up to you. But what you're doing is you're going to find that the log of 216 divided by the log of 6. And you want to hit enter, and you get that 3. And then you just bring the 4 down. So I probably would have found that first and then divide by 4. But either way is fine. Either way you want to do this problem. On this problem, I want to get the x by itself. Now, I can't write 20 in terms of 4, because if I take 4 times 4, I get 16 times 4 more, I don't get 20. So if you've seen previous videos, I can't use a property that I used before. What I can use though are logarithms. I like to use the definition. the definition for logarithms is this. And I don't know why it does that. It kind of irritates me that it does that sometimes. It just moves on its own. So you have a to the y equals x. Now that's the same as a log. Now here's what logs are. Logs are exponents. That's all they are. And so since the exponent is y, that means the log equals the y. Now the base is a. So the base of the log is the same. A. And then whatever is left over, the x goes there. There's no exponents here, there's no superscripts, that's a subscript. So what that means is I'm going to use the definition for this given equation. So start with the word log. The base is 4. Logs are exponents, so that means it equals the exponent, which is x, and then the 20 goes here. There's something else you need to be aware of. If you want to check this, you start at the base, and you go into circle buddy. A to the y equals x. 4 to the x equals 20. Circle. Don't be afraid to use it. And then there's a change of base formula. And all that change of base formula means is you can rewrite it as a log over a log. Just remember the base, which is 4 in this case, goes on the bottom. Base, bottom. And then the 20. And that's the exact answer. Or one variation of it. That's the exact answer also. If you want the approximation, type it in log 20 and make sure you close that parentheses if you need to. Divide it by log 4, close, enter, and you get roughly 2.16. And that makes sense. I'll tell you why. Because 4 squared is 16 and 4 to the third is 64. So the answer will be a little bit bigger than 2, which it is. Now there's another way using logs if you want to, and you may like it better. You can just take the log of both sides. It's just a preference. It's whatever you want to do. You have to remember though, if you use that, the exponent moves out in front. That's the only thing you have to remember. And this way probably is easier. If you notice, we get the same thing. Log of 20 over log of 4. And so we still get x is about 2.16. So whatever you want to do. On this example, there's a couple of approaches, but maybe you'll recognize that 16 is the same as 2 to the 4th. And that's what I want to do. And since we have the bases are the same, that must mean the exponents are the same. And this is what we're going to do to solve it. We're just solving the exponents set equal to one another. So now we're going to add 5 to both sides. And then divide both sides by 8. And that's about 1.125 if you want the decimal value. Now you may want to do a different approach. And if you like this method, then don't look at this. But I'm actually just going to put in log form. I like to use the definition. So log base 2 of 16 equals 8x minus 5. And then I'm going to rewrite this using change of base. Log 16 over log of 2 equals 8x minus 5. I'm going to go ahead and find log of 16 over log of 2. Log 16 divided by log 2. And we get our 4. And if you notice, same thing. So we're going to get the same answer because it's the same equation. So either way you want to do it. And there's actually an additional way, but I think these are two easiest ways. In this problem, we're going to solve for x. And there's no way I can get these two bases to be have the same base. 8, there's no power of 3 that gives me 8 because 3 squared is 9. So what that means, I'm going to use logarithms. I'm going to use a definition. I'm going to start the word log. The base is 3. Logs are exponents, so it equals x, and the 8 goes there. And then when you use change of base, that means that I put the log 8 on top and the base goes on the bottom. log 8 divided by log 3. We get about 1.89. Now if you want to, you can also do this. You can take the log of both sides, and then that exponent moves out in front. Then you divide both sides by log 3 to get that x by itself. And that's the same thing as that. I've already typed it in 1.89. So either way is fine. On this problem, it's already in log form. So what I'm going to do is I'm going to convert it to exponential form. Now exponential form, by definition, says this. Logs are exponents. And the base is the same for both. Log of the base same as the base of the exponent. So 3 is the base, so start there. Start the base. And logs are exponents. Because how you gotta know. Logs are exponents. So since 2 is equal to the log, that means 2 is an exponent. And then equals what you haven't used yet, which is the 5x minus 3. Now if you want to see it another way, start the base, and then you go in a circle, buddy. 3 to the second equals 5x minus 3. And so now this is the equation we're going to solve. The log is gone. The log is gone. So 3 squared is 9. Add 3 to both sides. We get 12 equals 5x. Divide both sides by 5. We get our answer. 12 over 5, also known as 2.4. But 12 over 5 is probably the preferred answer. Now in this problem, solving for log, it's a little bit more difficult. First thing we have to recognize is there's a property that says this. If you have log of m times n, that's the same as log of m plus log of n. We're actually going to go this direction. So if you get two logs being added together, it doesn't matter what the base is, you can combine them together as one single log by using multiplication. So it's going to be x times x minus 21 equals 2. Now this log, if you don't see a base, the base is always understood to be 10. It's called the common log. So now I'm going to convert to exponential form using the definition. Start the base, 10. Logs are exponents, so the exponent becomes 2. And that equals x times x minus 21. Now the reason why it's more difficult is because what's going to happen next. 10 squared is 100. X times x is x squared. X times minus 21 is minus 21x. You have a quadratic. Anytime you have a quadratic, you have to get it equal to 0. So I'm going to subtract 100, because 100 minus 100 is 0. And we have a quadratic equation that we have to solve. Now you can use the quadratic formula. You can factor if it factors. This one will factor, but you can use the quadratic formula. I'm going to show you what I might do if it were me, and I'm not sure how to do either one of those. First off, use the quadratic formula if you know how to. But I'm going to graph it first. Let's graph x squared minus 21x minus 100 and graph. Oh, my window's messed up, so I'm waiting for it to stop graphing. I'm going to hit zoom 6, which fixes my window. So it looks like it crosses the x-axis maybe more than once. If I hit zoom fit, let's see if I can find the other one. So it crosses there, and it's probably going to cross somewhere way over there. So what I'm going to do is I'm just going to change my x max, my x min to like, I'm going to keep it at -10, then I'm going to change that to like 50, and let's just count by 5s or something. I'm going to change these back to -10 and 10, because I don't really care how low. I'm just worried about the x-axis. Cross there, cross there. So these are count by 5s. So there's a couple ways I can do this. One thing is I can look at the table, and if I see anywhere where there's a y value of 0, that's going to help me out a lot. So let's go back to my graph. Since I'm counting by fives, because that's what my scale was fives. Looks like it could be negative 5, 5, 10, 15, could be positive 25. Let's just go to the table and just see what happens. Well, it's negative 4. So we got a one value there, negative 4. So let's go way on down to 25. There's a shortcut way of doing this, but I just do this. Oh, 25. So there's my two possible answers. How you like that? Huh? You could also use the quadratic formula or factoring, but hey, I can use my calculator also. Sometimes it'll help me find it. If the numbers are even ugly, sometimes I can still find it. Now the only thing is if I take my original equation, log of x, if I put a negative 4 in there, watch, log of negative 4, I get an error. You can't take the log of a negative number. So that means is x equals 25 is my only solution. On this problem, this equation, notice we have a minus sign. There's a log property that says, no matter what the base is, that if you have log base m divided by n, that's equal to log base b of m minus log base b of n. It's based on the exponent rules. When you divide, subtract exponents. Same thing going on here. And we're actually going that direction, which means we have two logs being subtracted. We can combine them together using division. So that's what I'm going to do. Take the log 5. Just think of the exponent rules. When you're dividing, subtract. So if you have subtraction, that means you're going to use division. S plus 14 over S plus 6. And that equals log base 5 of S. Now there's another property that says if you have log base b of m, let's just use x, equals log base b of y. Those logs like cancel out. That means that x equals y. That's kind of what's going on here. These logs are like going to cancel out, and it's going to leave us with s plus 14 over s plus 6 equals s. So I'm going to put the s over 1. I like to cross multiply, and that's what I'm going to do. Cross multiply. So we have s plus 14 times 1 equals s plus 6 times s. Now s plus 14 times 1 is just s plus 14, and then s times s is s squared, and 6 times s is 6s. Now since we have a square, that means I need to move everything over to the s squared side, so I have this equal to 0. So I'm going to subtract s, and I'm going to subtract 14. And we get 0 equals s squared, and that's 5s. Let me erase that, make it look better. Minus 14. Now to solve this quadratic equation, you can use the quadratic formula if you want. You can also graph it if you want. You can also factor if you want. I'm just going to use the quadratic formula in this example, which is x equals, it's actually not going to be x in this problem, it's actually going to be s. Negative b plus or minus square root of b squared minus 4ac all over 2a. I really would just rather graph it and not worry about it, to be honest about it, because it's going to be nice numbers I can find really quickly in my calculator. But just to change it up a little bit from previous videos that you may have seen from me, I'm going to throw in my a, which is 1, b is 5, and c is negative 14. So you got 5, 5, 1, negative 14, and 1. So we have negative 5. I have to do the easy stuff first. So 2 times 1 is 2, plus or minus. That's 25, and that's plus 56. That's actually 81. If you want to, type it in real quickly. 5 squared minus 4 times 1 times negative 14. I made a mistake somewhere. I made a mistake. What, 1? Is that what I needed? Yeah, there's my 81 that I knew was there. square root of 81 is a nice number. It's 9. I'm going to go to the right. So we have negative 5 minus 9 over 2, or negative 5 plus 9 over 2. Negative 5 minus 9 is negative 14. Just go on down. You want to? Can't hurt. Negative 14 over 2, or 4 over 2, which is negative 7 or 2. So I have negative 7 or 2 as my possible solutions. Since I have log of negative 7, I can't take the log of a negative number. The 2 was fine because it's positive and I don't have negatives anywhere when I substitute in. But I do get logs of negative numbers when I use the negative 7. So my only answer is x equals 2. For this example, notice we have two logs connected by subtraction. Think of exponent rules. When you divide, you subtract exponents. So that means that I can combine these together as one single log using division. Don't forget my base equals 2. There's a property that says this. If you're dividing, you can separate them by subtraction, which means you can combine them together using division. We're going from subtraction to division, subtraction to division. Now I'm going to convert this over using the exponent or log definition. Start with the base, which is 4. The exponent is 2. That equals what's left over, x plus 1 over x. Now that 4 squared is 16. I can put that over a 1 also because I like to cross multiply. Crisscross multiply. Hey, jump. 16 times x is 16x equals 1 times x plus 1. So we have 16x equals x plus 1. Trying to get the x by itself, so subtract x from both sides. That's the same as 1x in case you're wondering. 16x minus 1x is 15x equals 1. Divide both sides by 15. And you get your final answer of x equals 1 over 15. Just look at the equation. I don't see any issues as far as taking log of a negative number. So that's our final answer. On this example, notice we have two logs connected by addition sign. Well, there's a property that says, if you think about exponent rules, that when you multiply, you add exponents. And so the log property is just in terms of common log. If you have m times n, that's the same as log of m plus log of n. We're going that direction. So if you got addition, you can make it one single log property by using multiplication. X plus 7 times x minus 7 equals 5. Now I'm going to convert this to exponential form by starting with the base. Logs are exponents, so 5 is an exponent, and that equals x plus 7 times x minus 7. Now I'm going to do all kinds of work on this. I'm going to clean it all up. 2 to the 5th is 32. I'm going to multiply that out and get x squared minus 7x plus 7x minus 49. Those become 0. We have a quadratic because of the x squared. So that's x squared minus 49. Now in this case, since I don't have an x term and I only have the x squared, I'm going to add 49 both sides. And when you do that, you get 81 equals x squared. And that's actually nice because now I get to square root both sides. So when you square root both sides, don't forget the plus or minus. So you get x equals plus 9 or negative 9. Now I got to check. If I put in a plus 9, I get positive values for the log. If I put in a negative 9, that's not good. I can't take the log of a negative number. So 9 is the answer.